All right. Welcome to the first annual online award ceremony for mechanical engineering. Hopefully it's the first and last annual. You guys will be unique in this regard. So every year, the faculty at Tufts nominate a number of different students for different awards, and this is the culmination of those nominations. So what we're going to do is we're going to go through each award. Each student or pair of students will be introduced by a faculty member, typically the one who's nominated them, except in one case, unfortunately, one of the professors couldn't make it, and I will be reading what she wrote in her voice, of course. So Brianna's going to be moving the slides. So Brianna, let's go to the first award. Yeah.
Hi there, I'm going to be presenting this award. This is the Mechanical Engineering Graduate Teaching Award, which goes to Elliot Pavlovich. Elliot, I really enjoyed working with you this year in many ways. And along with my fellow mechanical engineering faculty here, wanted to recognize the incredible efforts that you put into helping students learn. I had the privilege of working with you in ME80, which is System Dynamics and Controls, this spring. And I was constantly impressed by how much effort you put in to working with the students. In the early part of the semester when we were on campus, you were always there, seemed to know up and ready to help students where when they had struggles with the homework or the projects. And they knew to go to you. I didn't see many people in office hours for a while because they went right there to find you in NOLOG. And that continued even as we went virtual with online meetings, office hours, and preparation help for tests right up to the end. So that was common in the other courses you helped with, like ME18. The effort was remarkable. So thank you so much, Elliot. Great job with all your efforts in teaching and supporting the department.
Thanks, Jason.
Hi, everyone. I guess I should just start. It is my great pleasure to present an award to one of my direct PhD students, Amin Dekargani. And this award is for outstanding graduate research. So Amin came to Tufts about 5 years ago from Iran, and he's my first graduate student and played a really key role in helping to establish my lab. It's been a real pleasure to watch Amin grow and develop as into a truly outstanding scientist and engineer over the years. And this award, Amin, is focused on excellence in research, and I really can't think of anyone that's quite as deserving as you, especially given the amazing year that you had in 2019. So in 2019, Amin was the co-author of 3 different journal papers. And sort of the crowning achievement of that year for him was a publication in the very prestigious journal called the Proceedings of the National Academy of Sciences. And in that, Amin published work on the main focus of his PhD, which is trying to understand how swimming bacteria are carried around in fluid flows. And that work has already made a huge splash, no pun intended, in the field. It's just a really fantastic piece of work. I'm very proud of all of Amin's accomplishments, and he'll be finishing his PhD this winter sometime. While I'm very sad to see Amin move on from Tufts, I'm also really excited to see what he's going to choose to do next. So congratulations, Amin, on this award.
Thank you, Jeff. I really appreciate it. It's been a pleasure to work with you and also to be in the mechanical engineering department. This wouldn't have been possible without your support and the department's support. And I really appreciate your help during my journey for the PhD. Thank you.
That's great. Congratulations, Amin.
Thank you.
So as we move towards the next award, I realize I don't quite know what the format looks like on the end of the audience. And so for those of us who are here, the students and the faculty, we know each other pretty well, but there may be some of you out there who don't know us, and maybe we should introduce ourselves. So you just had the chance to see Professor Jeff Guasto talk for a moment there about Amin. My name is Jason Reif, and I want to present the next award to Jordan Leweck. Jordan, it's been remarkable to work with you. We had a chance to work together during your junior year when you're thinking about what research directions you might take and where you might want to go. And there was this unique nexus where you were looking at a project that might combine computer science and mechanical engineering, those interests. And so you were willing to engage in something that seemed at the time to be a bit crazy, trying to take those skills and do something that didn't seem mechanical, particularly at first, until we started to think more about dynamic models and realize that what you're doing, which is trying to figure out how to track populations with limited sensor data using dynamic models, right, that are kind of built on all those skills that you developed over the years in mechanical engineering and computer science and brought those together. And I think the results were remarkable. As an undergrad, you're able to put together the nexus, or able to put together a paper, right? So there's a core of a paper there that went to a conference called the Winter Simulation Conference, hosted by a number of societies last year. And it ended up winning a Best of Conference award. So that was quite remarkable. And it's in recognition of that research you did and the achievements that you've already had, that we add one more achievement. So congratulations on the award of the Lloyd McGregor Trefethen Research Award, Jordan.
Thank you so much, Jason. Yeah, it was great to work with you and the whole research team, and very proud of what we made. Actually ended up presenting what we made when I got my first job out of college, and that was one of the main reasons I think why I got it. So thank you.
Congratulations, Jordan. Do you want to share where you're working next year?
I'm working at a drone company in San Francisco, and we did a lot of stuff on drones, so I kind of had that connection. Yeah.
Fantastic. Thank you.
Thank you.
And congratulations.
Hello, this is Mike Zimmerman, and it's my pleasure to see Max. And I haven't seen him in a while, but I've seen him in class a little bit. So I'm Mike Zimmerman. I'm a professor of the practice in the mechanical engineering department. And what that means is basically I work in industry and I teach with an industrial perspective. And the classes I teach are a polymers class, basics of polymer materials, and I also have developed a composite materials class. I've gotten to know Max this year because he took both of those classes. And in the first class, we learned about polymer materials and some special properties of polymers that are only related to polymers, which are the time-dependent and creep characteristics of polymer materials, which is really important in design. And we involved a company, Sensata, that gave us some problems to work on. And Max was in that class. And Max really excelled at a combination of thinking and doing, understanding the theory, designing some experiments, and doing some testing. And we did a presentation for Sensata at the end of the semester. And Sensata, the company, really appreciated all the work that the students in that class did. And I'll just mention that Max was a leader in his group. He was really someone that everybody in the group could look up to. The second class was composite materials, which is a very hands-on class, and the groups were to make composites, design composites, test composites, and they did a great job on their first two projects. And then we had to sort of go off campus for a while, and we gave them a project of working on some interesting design options on face masks, and Max dove into it and helped us think through some of the key aspects of what we could do to design a better face mask. I just want to mention quickly that this is called the Lloyd McGregor Trefethen Award, and I'm sort of sorry to admit I'm old enough to have met him. When I joined Tufts in 1990, he was actually retiring, and I had a couple meetings with him, and I was thinking back. One of the things when I met him, he was asking me, well, we actually went to one of the schools that I went to, MIT. We both went to MIT. He was asking me about what I disliked about it. I'm not going to mention that, but what we both liked about it was the motto was mens in manus, meaning minds and hands. And he was a believer, as was I, that the best engineers are ones that are thinkers and doers. And I think his career was about that. He did a lot of work inventing things like heat pipes. And I feel like Max is in that spirit. Max likes to both think about things, and he's a very good experimenter and doer. And I believe Max is going for a master's degree right now. I think he was thinking about fluids and materials, and I think he wants to do materials. And he's been working on making some equipment in the lab work, which hasn't worked in a long time, the drop tower. I haven't seen that work in about 10 years, but all I like to say is I was really glad to meet him. I think he's a great student. He did great undergraduate work, and I'm happy if he so chooses to advise him on his master degree. So Max, congratulations on this. It's well-deserved.
Thank you very much. And I really enjoyed the classes that I took with you. And as an update on the equipment in the lab, on the last day before we left for spring break and didn't come back, I did get it to work. So whenever I get back into the lab, I'm very excited to start working on it again.
Okay, great.
Thank you.
Hi, everyone. So this is Professor Jeff Guasto speaking again. So I have the great pleasure to present not one, but two awards to a really fantastic junior, Olivia Martin. The two awards are the Samuels Mechanical Engineering Prize, which is given out for overall achievement in mechanical engineering, and also the Class of 1898 Prize, which is actually a university-wide or a School of Engineering-wide prize for the citation is for high scholarly ability and a wide range of intellectual interest and competence. Olivia is a truly outstanding student who definitely fits the bill for both of these awards. For me as a professor, what I've found over the years is that one of the unfortunate things about being a professor is that when we meet and interact with an exceptional student like Olivia, we only usually get to see them for one class or maybe two. What I've seen from Olivia is that I've had her in one class so far, and I hope to have her again. Olivia was in my fluid mechanics class in the fall of 2019, and I was absolutely blown away by her performance. She scored about as close to a perfect score for the entire class as I have ever seen. And for that reason, I felt that she really deserved an A+, which is not, it's an optional grade at Tufts. We don't have to give out A+. And so it's quite rare. I think I'd only given out 2 or 3 prior to Olivia. So I thought that they were very uncommon grades until I saw Olivia's transcript. And I won't embarrass her any more than that, but to say that a lot of her other professors and instructors have found her to be very exceptional as well. And so she's received many more than one A+. What makes all of Olivia's accomplishments even more impressive is that she's also a multi-sport athlete. So she competes in track and field and also cross country. For any athlete, performing at a high level academically is extremely challenging. And Olivia handles all of this just with an amazing grace. What I'll sort of finish off on saying is that as I've gotten to know Olivia over the last year or so, one of the things that most impresses me about her is that she's not driven by status and accolades such as what she's receiving here, but rather she seems to have a really innate curiosity and a desire to learn. And that's what makes this award to her so special. And she's done really well in the classroom, and I'm very glad to see that she's also now pursuing research. So she applied for many different research internships over the summer, and she was accepted into many different programs. And she chose to I guess not go to, but she chose to participate in a program at Los Alamos National Lab. So I'm very proud of Olivia for that as well. So Olivia, congratulations on both of these awards, and we can't wait to see you back on campus as soon as possible. Thanks.
Thank you so much, Professor Gosto.
Hi, everyone. I'm Erica Kemmerling. And I'm really excited to be able to present the Mechanical Engineering Prize to two students who are very, very important to me. I've written a little bit about both of them. So first of all, Katie Melsky. I have been Katie Melsky's academic advisor since she first arrived at Tufts. My initial notes about her say, quiet, high achiever from Lexington who likes to skate and thinks the Tufts storms are too loud to sleep in. I kind of sympathize with that. However, I've been fortunate enough to get to know much more about Katie over the past 4 years. Katie doesn't just like to skate, she's literally one of the best synchronized skaters in the entire world. My 3-year-old daughter Liliana and I had the privilege to watch her perform with her team, the Heidenets, a few months ago, and I was astounded by Katie's talent and grace. Liliana has not stopped asking when we're going back to see the fancy skating team and also when she will be old enough to join. Outside of skating, I have been fortunate to have Katie as part of my research team for the past year. She has been invaluable to me in helping with an engineering education project focused on evaluating how students learn differently when solving homework problems that connect material covered in class to their own personal interests. Katie has become an expert at writing thermodynamics, fluid mechanics, and heat transfer problems on a variety of strange topics, ranging from designing a Frozen-themed roller coaster to effectively cooling a room containing a pottery kiln. I'm lucky to have her continuing this project with me over the summer and through fall semester. After writing all of this, I realized I haven't even talked about Katie's impressive GPA, which is why she's getting this award in the first place. But I think that's fitting because while her GPA speaks for itself, I want to make sure you all understand what an amazing person she is beyond her grades. So congratulations, Katie. Your award is very well deserved.
Thank you, Eric.
Sure. And the second recipient of this award is Chris Colcord. So a few words about him. I first met Chris when he declared the mechanical engineering major, and my initial notes about him from my advising book say, pardon my language, seems like he really has his shit together. Having known Chris for more than 3 years now, I would say this is a 100% accurate description. Chris is the only advisee I've ever had who has regularly contacted me in advance of advising period, volunteering all the information I usually need to nag students to send. He's one of the most organized people I've ever met, which has no doubt contributed to his academic success. Beyond his organization, however, I have found Chris to be a hard worker with an unusual knack for grasping difficult concepts. I was lucky enough to have him in my class earlier this year, and I found him to be an insightful student who asked interesting questions that made other people think. Chris was quite productive during his time at Tufts, even outside of class. He completed an internship at Dexi Robotics, during which he designed and implemented upgrades for Alfred, the robotic food scooping arm, and later worked with biomedical device and pharmaceutical clients through the company Fix. On campus, he spent a semester researching with Professor Luisa Chiesa, conducting experiments on critical current in superconducting tapes and performing finite element analysis simulations on multi-tape cables. Beyond his accomplishments, I have found Chris to be a warm, kind, and helpful person. His peers clearly respect him, and every professor I asked about him described him positively, using descriptors such as thoughtful, dedicated, and awesome. I am proud to call Chris my advisee and to present him with the Mechanical Engineering Prize.
Thank you so much, Erica. This means a whole lot. And I just wanted to say thank you to all the wonderful professors that I've had at my time at Tufts, and also all the students that I've had the pleasure to meet. They've really pushed me and motivated me to do my best. Thank you.
I cannot start video because host has disabled it. Okay, there we go. All right. So we got everyone. Yeah, okay, we got everyone here. Okay, so hi, my name is Brandon Stafford. I'm here to present this is called the James P. O'Leary Design Award to 4 individuals who were in most of them were in my senior design class. That would be Jana Sokolow, Giovanni Fava, Tassin Ken Sarlak, and oddly, Robert Rapucci. I see Robert Rapucci Jr. has shown up to accept the award. That's great, his son. So that's great. Yeah. So these guys, they were in my design class. Actually, Giovanni and Tosin were in my EN1 class. At the very first class I ever taught at Tufts, these two guys showed up. Giovanni was already like, I want to 3D print everything. And that actually persisted through the 4 years. These guys as a team built a autonomous, what, Robert, you're dropping out there? Is that what's happening? Anyway, oh, you're back. All right. As a team, they built an autonomous shop vac. So I run the makerspace at Tufts that has basically a room that's filled with sawdust all the time. And they built a robot that could drive around sucking up sawdust. And here's the thing, by the end of the semester, it actually drove and it actually sucked up sawdust. And it like would go in a kind of, not a random pattern, but kind of a zigzag pattern back and forth. And if it hit a wall, it'd turn around and it actually worked. And that's a, you know, you can sort of think like, yeah, you can buy an autonomous vacuum cleaner. Yeah, you buy this, you can buy that. But to actually build that from scratch, including building an impeller from scratch, it was a superlative effort, and I was very impressed by it. So thank you to you guys for building that. In the end, like, it doesn't matter, right? What matters is you learned like, hey, if we prototype this thing and iterate it, and when all the MOSFETs blow out, Tosin, you don't stop, you keep going. Like, having learned that lesson, that will take you very, very far. And I look forward to seeing what things you guys do in your careers, because I think you all have very bright futures ahead of you, which is why you get this magical award. So congratulations. I think that's it. Do we move on?
Thank you for this award, and we just wanted to thank Brandon for everything that he did for us. Thank you, Brandon.
Yeah,
Thank you. We'll miss you.
Thank you.
We're all still going to be in the world anyway. Like, we can still like email each other and stuff. Anyway, just saying.
Right. So it's my pleasure. I'm Chris again, still. It's my pleasure to introduce Walker for the Vin Mano Leadership Award. Vin Mano was a good friend of mine, still is a good friend of mine, and was within the department chair, then associate dean, and then he went on to be the provost of Olin, where he just retired. So clearly he understood the leadership thing. And when the department got together to think about who they would award this to, Walker's name came up across the board for a couple reasons. One, he's the head of ASME and has been trying to do a lot to bring the group together. But two, because no one had ever actually seen Walker depressed. So I took it upon myself to see if we could actually pull that off, and gave him a number of different assignments. Some are undergraduate research, where we tried to figure out issues with trombone bells, to the class last semester where I tried to make him make robots that shouldn't be made out of Lego, but he somehow managed to do all those with a smile on his face. So I'm sure he will someday be changing the world, and I look forward to claiming that I knew him when he still had short hair. So congratulations, Walker.
Thank you very much. Thank you for giving me all those tasks. It was fun, and I don't know if you will ever succeed. And depressing.
I will.
All right. So my name is Luisa Chiesa, and it's my pleasure to present the award to Matthias Aranguiz. He received a university-wide award called the Lieutenant Commander Robert James Manning Memorial Prize, which recognizes engineering students who show a commitment to excellence. So Matthias, in addition to majoring in mechanical engineering, he's also majoring in physics and is minoring in mathematics. He has been a pleasure to have in class. I had him in 2 of the classes in the sophomore year, and he's always asking intriguing questions to which sometimes I don't have the answers. And he's been working on team projects and observing how he works with others. He really cares about other people, and he's really caring of other people doing well. And so for that reason, he's also an outstanding mentor to other students. And among his accomplishments, he has been chosen as the head tutor in the ARC program, and he tutors first-year best student in calculus. So congratulations, Matthias.
Thank you, Professor Chiesa, and thank you to all the professors in here. I know I have a lot of you
And I want to just say that I hope everyone's doing well during these times.
Right. So the next one is the Georgia Marion Gowdy Prize. The Georgia Marion Gowdy Prize is actually for Outstanding Junior. We have two different nominations for this, or two different recipients of this. I will introduce one, and James Interrogator will introduce the other. So the first actually was an interesting story. One of my advisees came up to me and said she wanted to do some undergraduate research around making smart materials. And I said, that sounded great. And I said, but why don't you get some friends to join you? So it's a group. So she got some friends, and then she ditched the group, and just the friends continued on with the project. And so that was Naomi and another student who actually spent the semester fighting Bluetooth and fighting all sorts of different materials to eventually make a set of gloves that you could type Braille out just by putting the gloves on and moving your fingers. It was pretty cool. So they actually had a full Braille typewriter built into a set of gloves. So she also has done extremely well as a student, but I thought the gloves were far cooler than the grades. So Naomi, congratulations. And I like your background. I assume that's a fake car background.
Yes, of course. Of course it is. But thank you so much. I really, really appreciate, all the kind words and your mentorship. I'm sorry, I'm in a little bit of a funny situation, but I really appreciate it. I learned so much. It was such a great experience.
Me too. Congrats.
Hello, so this is part 2 of that award. I'm James Intriligate. I'm a professor of the practice in the Department of Mechanical Engineering, and I run our Human Factors Engineering program here at Tufts. And today, the person I have the pleasure of introducing is William Lau, and he's the other recipient of the George and Marion Gowdy Prize. So let's see. Similar to what Professor Rogers was just saying, I actually first met William in a hallway conversation as well. We started chatting and discovered we had a shared interest in robotics and biomechanics and soft robotics and things like that. And suddenly, 6 months later, I had about a dozen students working in the lab that William had recruited, interviewed, and essentially was supervising, running 3 parallel projects. One of them was looking at sort of the biomechanics and human factors of soft robotics. One of them was looking at actually printing soft robotics. And then there was another team that was just looking at making new toys. And William was fantastic and ended up running all of those things brilliantly. After that, he has gone from strength to strength. He did an internship at Beth Israel Hospital last summer, looking at spine problems, cancer, sort of the biomechanics of the spine. He's been also critically important and the central player in one of our projects looking at building a back support system, sort of a soft robotic back support system. In addition, he's also been selected as a Laidlaw Scholar, which is a prestigious thing that Tufts has to finance students to work for a summer and an entire year essentially on research projects. And so he's been carrying on his work in the biomechanics and soft robotics space. He was so good in the Laidlaw program, and they loved him so much that he actually managed to somehow pull in 2 other Laidlaw scholars. So I sort of attribute my 2 new Laidlaw scholars to William's efforts as well. So we now will have a team of 3 Laidlaw scholars working on this project. So in addition to his incredible research work that he's been doing and organization and team efforts, he's also been very active in student programs around the university more broadly. So he was the secretary of the Engineering Student Council 2 years ago, and he was, last year, and this year he's been the president of the Engineering Student Council. And because he's graduating a bit early, he's actually now stepped aside as president, and now he's sort of senior advisor to the Engineering Student Council. He's also founded several clubs, or been one of the founding members of the Biomechanics Club at Tufts and the Soft Robotics Club at Tufts. So he's an incredibly active person in general around Tufts. And actually, another example of his involvement more broadly is that in the last few months, as the COVID-19 crisis has been coming on, William's been incredibly active in designing, building, 3D printing, and mailing all over the country bits of bits and pieces of hardware that can make it possible, for instance, to use snorkels as PPE within hospitals. So a very deserving recipient of the award. Well done, William. Yay.
Thank you so much, James. Thank you so much. Oh my God. Thank you so much for your endless support and guidance. It's my luck and honor to know you and be part of the research team in the Human Factor Lab. And thank you to all the professors that have helped me and teach me in the classes. And Mom and Dad, if you're watching this midnight back home, I miss you a lot and I hope you made you proud. And to my beautiful girlfriend, Claudia, you have always been there for me through this hard time. Miss you and lots of kisses. Thank you.
Apparently, I am not allowed to start my video. There we go. Hello, everyone. My name is Professor Madsen, and I have the honor of presenting the Benjamin G. Brown Scholarship to Cortland Priest. What I'd like to do is briefly read what the Benjamin Brown Scholarship Award is announced in our, as far as what Tufts gives this award to. It's awarded to a senior who has shown promise in scientific research in fields other than chemistry. And I wondered about that and thought, well, why is it that we don't want you researching in chemistry, Cortland? So I took a look at your transcript, and it appears that you went ahead and placed out of Chem 1 and placed out of Chem 2. And therefore you never took a course at Tufts. So maybe that's why. Maybe you should have thought about just going ahead and retaking one of those so that it wasn't limited by that. But seriously, Cortland has done some fantastic research as part of the mechanical engineering department. He worked in his junior year. He applied for an internship at NASA's Marshall Space Flight Center and did research there, looking at how to fabricate samples and build up a facility in order to help us test our ground-based research in support of our flight investigation. That we do experiments on electrostatic levitation, and that's, I'm sure he could tell you all about that. But then he continued on and did a senior thesis and received high honors for his work here again. And what he did for us here was he took a facility that was not being used over at BU, and in collaboration with one of the professors over there at BU and myself, the professor's name is Glenn Holt. He's a former astronaut, and he did research on how droplets will be affected by acoustic fields. And Cortland built up a facility at Tufts and started up the high-speed camera system that we now currently use, and basically started a facility from scratch for us and came up with some really, really good research. So in honor of his achievements, this is a school-wide award. It is not just mechanical, it's not just School of Engineering, it's the entire Tufts Art, Science, and Engineering. And I want to congratulate Cortland on doing fantastic work while he's here, and including continuing on with his work that he started as part of his senior research project. And just want to thank you for all the good experiences that we had, and wish you the best as you continue on.
Thank you, Doug. It's been an absolute honor to be a part of your research group and be able to contribute in the ways that I have. Yeah, I'm looking forward to seeing what the future holds.
Thank you.
Okay, the next one is the Me Jonathan Taylor Prize for Ricky Kaufman. So unfortunately, Deborah Sumter, who nominated Ricky for this award, could not make it, so she gave me something to read. So here it goes. Here are a few words his research advisor, Professor Sumter, had to say about Ricky Kaufman. Ricky is a creative, self-motivated, interdisciplinary researcher. Over the last year, he has been exploring racial injustice in rooftop solar deployment, combining skills from his mechanical engineering and sociology degrees. To maximize the impact of his research, he has presented both local and international energy conferences and will be submitting his research for journal publication shortly. His holistic thinking overcomes social and political obstacles as he passionately works to advance clean energy and promote energy justice. It's a great pleasure to present Ricky Kaufman with the Me Jonathan Taylor Prize. Congrats. You're on mute. All right.
All right, hello again. It's Luisa again. It is my pleasure to introduce Tassia and say that she won this university-wide award, the Audrey Botway Grass Science Award, which is given for outstanding academic work in any of the sciences. She is a double major in mechanical engineering and applied mathematics and excelled in all the different areas that she touched at Tufts. She's done research with a math professor that led to our publication. I think it has to do with some politics and trying to calculate gerrymandering of the political network in the US. She worked with Professor Kemmerling inside our department, and she's also an accomplished athlete and competes with the diving team at Tufts. On a personal note, having been her advisor through her time at Tufts, I cannot be more proud of her today. Yes, I admire all of her academic qualities, but the thing that makes me the most proud is witnessing your growth over the last 4 years. So Tassia, I'm really proud of you. You gained the confidence that allows you to take risks and that will make you an excellent engineer, wherever your path will bring you. So congratulations, I'm really, really proud.
Thank you, Louise. I really appreciate it. I know that I couldn't have become the person I am without all your help and all the help of all the professors here. So thank you very much.
Hello, everyone. So, yeah, I'm Hoda Kushar, and I'm happy to present two recipients of Howard Sample Prize Scholarship in Physics from ME Department. The award is given to students who show outstanding performance in Physics 11 and Physics 12. So the recipients are Olif Cordova and Teddy Robbins. I had Olif and Teddy in Mechanics 1 and Mechanics 2 classes this past year, and we're so pleased that Teddy and Olif received these awards from physics because they indeed go above and beyond in physics work within our engineering courses. So Olif has a great passion for fully comprehending the logics behind the theories we discuss in class. In mechanics classes this year, Olif was always interested in going beyond the scope of the course to better learn the topics and satisfy his curiosity. It was fascinating to watch how he thought outside of the box when approaching the problems. And he showed great maturity in his thought process that was incredible for a sophomore. And we are going to benefit from his talent in our future mechanics courses. Also, Teddy is passionate about analyzing complicated mechanical systems. In mechanics classes this year, Teddy showed creative and curious thinking as he developed unique approaches to solving problems and applied the skills and knowledge from across many different courses. And he was also the first student to realize that a simple computational tool could help us analyze a system more thoroughly or more generally. And we'll be using his sinusoidal shaped kinetic sculpture as an example for future students for many semesters to come. So congratulations to both.
Thank you, Professor Koshiar, and thanks to all the professors, family, and friends who have motivated and helped me throughout my time at Tufts.
Sure, happy to have you here.
Thank you very much, Professor Koshiar. It was a great privilege for me to have been in both of your classes. And I can't wait to work with you this summer on our research.
Sure, can't wait either. Okay, thank you.
Hello. Oop. I guess I'll go first. This is I'm James Intriligator again, Professor Human Factors. We're now moving to the De Flores Prize in Human Factors, in Human Engineering. And there's two recipients. I have the pleasure of introducing the first one. So I'm going to be introducing Corey Lampedusa, who has been working with me for the last few years and is a fantastic student and a wonderful person. She first came to me as a Lewis Stokes scholar and did some wonderful work last year looking at the possibility of doing design work in virtual reality. And she spent quite some time interviewing designers, putting together surveys, designers, going through some in-depth analysis of the entire design process. And she ended up kind of designing a new program to help designers design, which is pretty cool. She even then started programming it herself, and unfortunately the semester ended. So the next year I should say, I sort of expected to continue with that project, but she had decided that she had a newfound passion in computer programming and virtual reality and autonomous systems. So we've spent the last year working on a project, trying to look at how we can study people in autonomous vehicles within a virtual reality autonomous vehicles simulator. And Corey wrote much of the software to do that. She designed the experiments, and we're going to be collecting data on that next year. In addition, she just finished taking her first class with me, and I had the pleasure of having her in my Human Factors for Product Design class. And in that class, she and her team did a wonderful project designing a new system that could help people who are at home stay connected to their healthcare providers, if you will, sort of a connected health project. And she was one of the powerhouses on that team, leading the efforts there. And actually, at the end of the project, both the client, there was a client on that, and another professor who was kind of a guest judge commented on how professional she was and brilliant and articulate. So I'm really happy to give her, award to her, name her as one of the recipients of the De Flores Prize. And I'll pass it to Professor Chiesa to talk about the other.
So the second awardees of the Flores Prize is Akshita Rao. She's double majoring in both biomedical engineering and mechanical engineering. And as a tough summer scholar last year, she developed a heart on a chip, a bioelectronic platform that measures the effects of hypoxia on cardiac electrophysiology with Professor Brian Timko. I have no idea what I just read, but it sounds amazing. So congratulations. She actually has publication for this work. And besides that, she's involved with TaskMake, and she's a volunteer at the Museum of Science. She's very talented. I have had her in 3 different classes, and I can tell you she has the best iPad class notes ever with 1 million colors, and I love seeing that. She's great at sketching and design, and one of her projects involved designing better storage option for college students. And she and her team came up with this beautifully made hexagonal modular storage design that was made with wood. So keep it up, Akshita, and congratulations.
Thank you so much, Professor. Yeah, thank you so much. Just wanted to say thanks for the chance to work in the lab the past couple of years, and thank you also to my family and friends watching for all the support and great encouragement and stuff like that. Thank you.
So I'm back again. Hi. I have the honor of presenting I guess it's the final award today, I believe. I think that's true. And this is the Human Factors Engineering Prize. And actually this student, Aiden Schertz, has won both that and also the Navy V12 and ROTC Memorial Prize. So Aiden's awesome. She's been a student here for her entire career, and she's also been in ROTC. She's into flying, if you will. She loves flying, aviation, and in fact, that was one of the things that brought her into the field of human factors originally. She was interested in sort of understanding cockpit design, redesigning sort of the space that aviation takes place in, and understanding how to make it more usable, if you will, from a human factors perspective. She has excelled in all of her design work at Tufts. She's also been involved in quite a few other activities around Tufts. She's been part of the Tufts Food Rescue Program and has been involved in the STOMP program, kind of teaching engineering skills to young kids. In one of the classes that she took with me, ENP 162, which is human machine system design. She did a brilliant project looking at designing an augmented reality system to help teach music and how people can play instruments better. Really clever design there. She's now getting ready to go off to be a Navy pilot, and she plans on flying helicopters in the future. So great work, Eden.
Thank you. Yeah, I actually just had my commissioning ceremony like an hour ago, so I'm happy
Wow.
I could come in.
Awesome. Live from the Navy. That's great. Congratulations.
Thank you.
All right.
All right. So that ends the very first ever completely virtual award ceremony. I wanted to take this moment first to thank Brianna for pulling it all together and developing actually new technology to make it all happen. And I wanted to thank all the awards recipients for actually zooming in and helping us congratulate you, at least from afar. So one last round of applause for everyone that got the awards. A virtual applause. I don't know how that's actually done in the real world. And thanks a lot for coming. And a bunch of you, I'll see you tomorrow. Probably in the same shirt. So thanks for coming.
Thank you, Brianna.
She's not listening to you. Thanks, Louisa.